Let's look at designing a study with generative AI. I'll show the Julius session where I designed an experiment plan and some artificial data. So let's go see that. So I just loaded up Julius. I didn't upload a file. I said I want to plan a series of measurements. I want to use different pH values and measure the reaction time, reaction percent yield. Originally, here I was doing just a pH study with no temperature. I want to run each pH value 3 times. Trials take 10 minutes. The workday starts at 9 a.m. Make a table with the following columns. The data type should be artificial, just so we're recording on every single line. This is not real data to avoid any future confusion. Um, I told it to just use randomly generated yield amounts between 20 and 40. So it wrote some Python code here that we should, if we were doing this for real, we should really spend time investigating how it's doing this. And it gives me this data table, um, and it's just showing me the first 5 rows here. Um, and I asked it, you listed the pH values in increasing order. What are the pros and cons of that? And while alternatives exist that might be better, I hadn't told it to do to do the pH values in increasing order by time of day. I just told it what values I wanted and then what time of day and said basically time goes on in 10-minute chunks. And it did what most people would do. I mean, it's not a person, but what most people would do is just put the pH values in increasing order rather than random order. So it's telling me pros and cons. Well, increasing order is simple, might be physically faster. It is talking about maybe an instrument warms up or the chemicals slowly change. But it's not very clear that this is actually bad because it's introducing confounding variables. It almost sounds like it's making it sound good. So I'm not happy with that. But it points out that this confounds pH with time. And so any increase you see through the day might be due to the pHs or might be due to whatever other variables were going on. So at least it pointed that out once it designed the study the wrong way. So this is why we need kind of Stat 101 statistical thinking, because the machine didn't design the study carefully the first time, right? And then it offered some other ideas like fully randomized, block randomized, which is what I ended up doing for the other video we just saw. Um, Sometimes interleaved is okay. This one is like go low to high and then go high to low and then go low to high. And then there's something really fancy called Latin square that would be in a 400 level stats class. So don't worry about it for now, but at least it's giving us these various ideas, but it still got it wrong to start with. Um, so then I said, let's go with the block randomization. Please add a column to the table that has a block number. So I did that. So the main lesson on this, and then I said, okay, now let's do a combination of pH and temperature, randomized within blocks. So that's what I used for the previous one, but it was just using yields that were just random between 0 and 20, not affected by pH and temperature. I said export that to a file. And then I said I want to create new artificial numbers that has a peak at a certain place. And then I talked with it about like, well, what function would do that? Do I want the minimum to be 20 everywhere? No, I want the minimum to be 0 because if you really crank up the temperature, maybe the reaction won't run at all. So just had we were debating this, and then I told it to do something, and it said, "Well, that's actually impossible." So I said, "Use this." That's like the spread of the peak, and it went and tried that and said, "You proposed this." But that went wrong. So then I changed what I said. Um, let's see. So I said, okay, let's use this. And then it went on to okay things. So the big lesson from this video is even if you are saying, hey, let's design the study, it still designed it wrong in the first place. And it's up to our critical thinking skills to say, well, we need to be thinking about all the statistical stuff and confounding variables.